Okay, we're going to continue our discussion of ocean currents now. And the next thing we're going to see is this curious thing that happens along the equator. Right along the equator, in between the north and south equatorial currents, we get a smaller current that's called a countercurrent. You can see it flows, in a sense, the wrong direction. You might think this is be kind of strange, given that when you think about those wind belts, the winds are always pushing the water from east to west. But you might remember from chapter 6 that right in the middle, along the equator, there's an area of very weak winds that's called the doldrums. And what that means is that all the water that's being pushed over to the far side of the ocean basin, it's kind of got a slope to it. So it's actually higher on the west side than the east side. Same in the Pacific. The ocean's actually higher over here than over here because of the wind blowing the water west. And this equatorial countercurrent forms, the water's literally flowing downhill. It's flowing down a long slope from the west side to the east side of the ocean. It's a small current, but its origin is kind of interesting. Now, a much larger current is a big current I'm gonna put here next, that flows around Antarctica. This is called the west wind drift. It's the only current on Earth that can flow all the way around the planet without bumping into land, because this stretch of the Earth is the only place where there's no land. It's all continuous ocean. And so those prevailing westerly winds, as they push the water along, they're able to push that water all the way around Antarctica. And what this does is it really isolates Antarctica from the rest of the world. There's no way any of this warm water from, for example, the Brazil current or the Aegean current, none of that warm water can even come close to Antarctica. And Antarctica is thus exceptionally cold, much, much colder than, say, the North Pole, which gets a little bit of warmth from this North Atlantic current sometimes. So those are the main currents of the world and the forces that make them go.